Hi 10th class, how are you? I hope all of you are extremely fine. Today I am presenting metals and non-metals. The most requested topic is extraction of metals. This topic is very important. 3 marks questions or 5 marks question can be asked from this topic. Stay with me till the end. First, we should study minerals. Minerals are the compounds of metals present in the Earth's crust. Discovery of the metal is the most significant finding that has revolutionized the world. The Earth's crust is the major source of metals. The metallic compounds generally found in Earth's crust is called minerals. A mineral from which an ore is economically, easily and quickly extracted is called an ore. So we can say all the minerals are not ores, but all the ores are minerals. For example, bauxite, cryolite and clay are the minerals of aluminium, but bauxite is the ore of aluminium. Aluminium is extracted easily and quickly from bauxite. So, when we select an ore, we should see three things: abundance, easily and cheaply separable, high metallic content. A mineral from which a metal is easily, economically and quickly extracted is called the ore of the metal. For the extraction, we should know the reactivity series. Here, you have already studied this: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, nickel, tin, lead, copper, mercury, silver, platinum, gold. We have studied this. So the first topmost, that is potassium, sodium, calcium, magnesium, aluminium. They are highly reactive. They are most reactive. We cannot see the metals in free state. Zinc, iron, nickel, tin, lead. They are moderately reactive. They are in the form of carbonates, sulfates or oxides. Copper and mercury, silver, gold, all these least reactive, and copper and mercury are found in sulfide ores and oxide ores, and silver and gold we can see in free state. These are the major steps involved in the extraction of metals. First, the ore. We have to select the ore. We have to do the enrichment of the ores. What is enrichment? Another word is concentration of the ore. For this, several techniques are there. Washing in a stream of water, then froth flotation, magnetic separation, leaching. All these are concentration methods. When we concentrate an ore, the metallic content will be maximum and it will be free of gangue, that is impurities. We usually get the ores from Earth's crust. So it will be having impurities like sand, dry leaves, then soil, all this. These are called gangue. This we can remove and the pure ore is taken. Three types of metallic ores are there. The first, metals of high reactivity, then metals of medium reactivity, metals of low reactivity. We have already studied. Metals of high reactivity like potassium, sodium, calcium, magnesium, aluminium. These are reduced by electrolysis of molten ores. Why the electricity is used? You know, these are highly reactive. For the most reactive metal, we have to use the strongest reducing agent, electricity. When the molten ore is electrolyzed, pure metal is formed. Why molten ore we have to take? When molten ore is taken, it is in the form of ions. So sodium chloride, if it is in the crystalline form, it does not conduct electricity. When it is in the molten form, it will be in the form of Na plus and Cl minus, and when electricity passes, sodium and chlorine gas is formed. We get sodium on cathode because you know metals are electropositive in nature. They move towards cathode. What reaction taking place at cathode? You know, sodium, metals are always electropositive. It accepts electrons from the cathode and changes into sodium metal, and it is collected or it is deposited on cathode. And at anode what happens? Chlorine is in the form of Cl minus ion. So the Cl minus ion moves towards anode. There it changes into chlorine gas and electrons are removing. At anode what happens? 2 Cl minus changes into Cl2 and 2 electrons it is sending out. Then metals of medium reactivity, that is zinc, iron, nickel, tin, lead. These are in the form of carbonates and sulfides. Carbonates, for carbonates we have to heat in the absence of air, that is called a calcination. That a clue is there, CC, carbonates, calcination. And for the sulfidose, we can heat it in the presence of heat, that is called a roasting. When we do this, the carbonate ores and sulfide ores will change into oxides, metallic oxides. So metallic oxides are formed. This we can reduce using carbon. This oxide we have to remove, no? Metallic oxide. This if we remove, we get metal. So for removal, if we use carbon plus oxygen, carbon monoxide is formed and metal is reduced. This zinc is in the form of carbonates as well as sulfates. If we are taking zinc carbonate, first we have to change it into oxide. So zinc carbonate can be changed into oxide by, if it is carbonate I told you, by calcination. What is calcination? Heating in the absence of air or heating in the absence of oxygen is calcination. So when zinc carbonate is heated in the absence of oxygen, zinc oxide and carbon dioxide is formed. And if the zinc ore is in the form of sulfide, the process is roasting. Zinc sulfide plus oxygen. Here zinc carbonate only we are heating it, but here in the presence of oxygen, so oxygen is added. It is changing into zinc oxide and sulfur dioxide. We are getting zinc oxide in both the cases, oxide form. Now we have to reduce it. We have to remove this oxygen. For reducing this moderately reactive metal, coke, this is a form of carbon, it is used. So zinc oxide plus carbon, zinc plus carbon monoxide, we get the metal. Then metals of low reactivity like copper and mercury. Copper, mercury, silver, platinum, gold, all these are least reactive metals, and silver and gold, it is in free state, that electrolytically purified. Here copper and mercury, they are in the form of sulfide ores. You know, for sulfide ores we have to do roasting. This is very important, children. You have to study the equations also. Cinnabar is the ore of mercury, that is mercuric sulfide. It is called a cinnabar. You know, sulfide ores, you have to do roasting. So HGS, mercuric sulfide, in the presence of oxygen, if we heat it, it changes into mercuric oxide and sulfur dioxide. 2 HGS plus 3 O2, 2 HGO plus 2 SO2. Then this HGO, that is in the oxide form, we have to remove the oxygen. So we have to reduce it. But here no need of reducing, just heat it. It undergoes self-reduction and metal mercury is formed. This we can refine to get pure metal. Copper is also a low reactive least reactive metal. Copper sulfate. First, addition of oxygen, that is here roasting. We are heating in the presence of oxygen. Cu2O is formed. Copper oxide is formed. Then this copper oxide plus copper sulfate is all, it is there, no? So copper oxide and copper sulfate combines to form copper, and sulfur dioxide is sending out. Very important reaction is thermic reaction. This can be asked for the exam. It is a displacement reaction. Here you can see sodium, calcium and aluminium, highly reactive metals. They can displace metals of low reactive metals from their compounds. Here, this is a low reactive metal iron. Its compound is Fe2O3, Fe3 oxide. If you are using aluminium, displacement reaction taking place and iron is formed. This process you can see Fe2O3 plus 2Al, 2Fe plus Al2O3 plus heat. That is, it is highly exothermic reaction. Because of this, iron becomes red hot and it melts. This process, the reaction of Fe3 oxide with aluminium, is used to join railway tracks or cracked machine parts. This reaction is known as thermic reaction. So this iron becomes red hot and it can join the railway tracks or cracked machine parts. This equation also you learn by heart. I hope this is clear to you. If you like my class, like, share and subscribe to my channel Rashis Classes. For new updates, press the bell icon. Stay healthy, stay happy. Thank you.